All right, so today's learning target, I can find missing parts of right triangles, and we're just going to be using right triangle trigonometry here, okay? Even though we're on video, please make sure you guys are asking questions because your questions might be something other people would have asked, so do not be shy about that, okay? All right, so I have a right triangle here. You'll notice that angle C is my right angle. Side C is my hypotenuse. You'll see that angle A is 28. Side A is 10. The side letter always corresponds to the angle it's across from, okay? You'll especially notice that here with the B's then. This is angle B right up here, so across from angle B would be side B, all right? So we're given a little information. We know this angle here is 28, we know this angle here is 90, we know this side is 10, but then there's three things we still don't know. I want you to be able to find those missing parts, and you've done this before in geometry, but maybe it's been a little bit, so that's why we're going over this. Okay? All right. First of all, I will open it up to you. Are there any things that you feel like you could figure out, either angle B, side B, or side C?
All triangle angles add up to some other
180.
Do all angles in a triangle add up to 180? You betcha they do. So if this is 28, this is 90, that means angle B would have to be 62 degrees. Okay? So yeah, that one's nice. You were given two angles, pretty easy to find the third one then because all three angles do have to add up to 180. So now I got these sides here. Alright, I got two missing sides on a right triangle. Now if I only had one missing side on a right triangle, I could just use what theorem? Pythagorean theorem to figure out the last one. But I got two missing ones. So Pythagorean theorem won't work. You got two variables. This is where that trig is going to come in, all right? Sine, cosine, tangent stuff, all right? Does anybody think they could come up with an equation using sine, cosine, or tangent that would help us to find one of those variables that we do not know the length? You might want to give it a shot.
it's the opposite of the cosine thing. That's
Or you want to use a reciprocal one even?
cosine.
Don't make it so hard.
-1
Jeez.
of this. That's I remember doing.
Oh, you remember using inverse? Yep, cosine to the -1 power. We won't need that yet on number 1 here. We'll need it on number 2 potentially. But you're working a little too hard than what you need to. It's all right, I'll help you out here. Let's say I wanted to find out side C here, okay? Side C. I know that this angle right here is 28. I know the side opposite the 28 is 10. And I'm trying to figure out my hypotenuse. If I know the opposite and want to figure out the hypotenuse, I'm going to use sine. Because sine involves opposite and hypotenuse. So the equation I would set up would read the sine of 28 degrees equals opposite over hypotenuse. So the sine of 28 degrees equals 10 over C. This is an equation that we can solve because there's only one variable in that equation. Anytime you only have one variable, you should be able to solve for that variable. Now, how in the world do you solve for a variable when it's on the bottom side of a fraction?
Multiply by 10? No, it would be 1 over 10.
Correct. You could multiply by 1 over 10, but even then, doesn't the C still stay on the bottom of the fraction? Because then you just have 1 over C. At least you got rid of the 10, but C still isn't by itself. So I like the idea of getting rid of the 10. I usually take a different approach, but we could go that direction. Is there another way where I could just do something so we don't have a fraction or we don't have C on the bottom?
I was just gonna say put sine 28 over 1 and then cross multiply.
Okay, that's definitely a way to do it. He's saying, I'm going to do it differently, but what he's saying is, it ends up being essentially the same thing. He puts this over 1, and now we have what's called a proportion. And how do you solve proportions? you cross multiply, right? Okay? A lot of times, what I think when I see this is like, okay, well, I don't want a fraction, so I'm going to multiply by c. I'm going to multiply by the denominator. What happens when I take 10 over c times c? What happens to the c's right here?
Cancel.
They cancel, and all I got's 10. So now I have c times the sine of 28 equals 10. Now I don't have a fraction, right? If I get rid of fractions, life's usually a little better. So now I have c times the sine of 28 equals 10. What do I need to do to get c by itself? Divide by the sine of 28. Now you're going to need a calculator. So these obviously cancel, and c will equal 10 divided by the sine of 28. I would like you to please use some sort of calculation device to find that answer. If it has to be a phone right now, fine. Phones are definitely not real easy to work with when it comes to sine, cosine, and tangent. You can Google trig calculator, I'm sure, and you'll find something online you could use. It'd be great if you could purchase some sort of calculator, even something basic like that. Those aren't probably more than 15 or 20 bucks, even if that. They would definitely do the trick for you. Some phones will work if you know the order to push them. All right, but every phone's a little bit different sometimes. What are you guys finding for 10 divided by the sine of 28?
36.9.
36.9. What'd you get?
I got 21.3.
Yeah, that's what I got.
21.3.
That's like what?
10 divided by the sine of 28. Is this a phone or a calculator you got? Phone? Okay, let me see how you're doing it.
If you can see the screen.
Yeah.
So 10 divided by 28 sine. Oh, I see. See what this says RAD up here?
Yeah.
That would put you into radian mode. And right now, since we are working with degrees, we want to be in degree mode.
Got it.
So now, if you did type it in the correct order. There's your
There we go.
21.3. Any luck on 21.3 on that calculator? So do 10 divided by 28 sine equals. Oh, you are also in radian mode. Sorry, hit your degree button. Now try that same order that I gave you there. This is why phones stink. There's your 21.3. Okay. Maybe you can put. Shelby had hers.
Yeah, I keep forgetting it. I got
Did-
it from her, but it's,
Home somewhere.
it's my desk.
Yeah. Yeah, if you can find that, that'll help you a lot. Okay.
Mhm.
All right.
So you have to do the 10 first.
So C is about 21.3. Hopefully you're able to use a calculator to get that answer. Again, if you're struggling with that, let me know so I can come help you a little bit.
Now can't we do Pythagorean's theorem?
We can do Pythagorean's theorem. The problem is, isn't this a rounded answer?
Yeah.
If you want to do Pythagorean's theorem, I'm going to make you not use the rounded answer. I'm going to make you use all those decimal places when you do Pythagorean's theorem.
Yeah, no.
Okay. So let's just use trig again then.
Yeah.
Let's just use a different trig. Let's not use sine, let's use a different trig function. Let's use cosine or tangent to help us find angle B. Which one do you think would be best? Both work, but which one do you think would be best to help us find, I said angle B, I meant side B. Which one do you think would be best to find side B?
Sine.
I heard sine and tangent, what do you guys
I
think?
think
What if you do sine if you were using the angle that B was at? Like if you use the 60 degrees?
So if you use this one up here and say the sine of that equals B over C, again, yeah, absolutely, that works.
I was thinking.
But I want to try to avoid using this because this is a rounded number.
That's why I said tangent angle B.
So you think use tangent
It's
instead?
opposite over adjacent.
So that way you can do this over this, or if you're using 28, this over. That way you can use the 10, and because you know 10 is 10. I mean, it's not rounded. 10 was 10. Try to avoid using the one you already had to round because it might cause your last answer just to be off a little bit. Okay. So do we want to do tangent of 28 or do we want to do tangent of 62?
28. Because 10 will be on the bottom.
28, because then B will be on the bottom and it'll be a lot like the one we already did.
Oh, yeah, option over 50.
Okay. If you use the 62, then B will be on top. Thoughts? Both work, guys. There's not a.
I
There's,
don't know.
I'd rather go like the.
Like,
all right. Tangent of 28 would equal what over what? Tangent of 28 would equal 10 over B. What do I do to both sides?
Multiply by B.
Multiply by B. So then B times the tangent of 28 equals 10. Divide both sides by the tangent of 28. And B is about how much?
18.
18.8? Okay. Alright, I do like going through and making sure my answers make some sense. So I look at my answers. The hypotenuse was side C, correct?
Yeah.
Is that our biggest side?
Yes.
Yes, it is. So that's good. Side B was 18.8. It was my second biggest side, which is what it should be. Does anybody know how we know that side B? Not just because of my drawing either, okay? How do we know that side B needs to be the second largest side, Zach?
So the 90-degree angle is to the opposite of the hypotenuse. So we know that B is going to, at the very least, be smaller than the hypotenuse. And yeah.
Okay, I agree. It has to be smaller than the hypotenuse. Can you give me a reason, though, why it definitely has to be bigger than this side over here?
Because the angles are one is smaller and one's bigger.
So this angle is smaller than that one, you're saying?
Yeah.
because math said
Wait.
so.
No, okay. Because B is bigger than, angle B is bigger than angle A, so it would make the sides longer.
Very good. This angle up here was 62, right? A 62-degree angle is going to open up to a longer side than just a small 28-degree angle, right? So the shortest side will always be across from the smallest angle. Okay? So it should make sense. 28 is the smallest angle, so the side across from that needs to be the smallest side. Then angle B was a little bit bigger, 62, so that means side B should be bigger than side A, but nothing will be as long as the hypotenuse because the hypotenuse is always the longest one on a right triangle. Okay? How are we doing? Better on that now? After one time through? Okay? Alright, number 2 here. How is 2 different than 1? Take a look at it. What about them?
We're missing 2 angles.
We're missing
on
2
one side.
angles instead of missing 1 angle here. I was at least nice and gave you 2 sides though. Okay? How do we go about finding the missing parts of this one? And then use that inverse you talked about. Okay, Sam was right. It's going to involve an inverse, all right, to help us find any angles. How do we find the last missing side? Pythagorean theorem. Okay, so we can find the last missing side using Pythagorean theorem, but to find the angles, we're going to have to use inverses. And let me remind you of what that looks like a little bit here. Would you guys agree that the sine of angle A has to equal 12 over 18? Does that make sense based on the picture? Because sine is what? Opposite over hypotenuse, okay? So if the sine of angle A equals 12 over 18, do you see how this equation only has one variable in it again? If you can write an equation with one variable, you know you're going to be able to solve it. Okay, or there should be a way to solve it. I got to get rid of sine. How do you get rid of addition? Subtraction. How do you get rid of multiplication? Division. How do I get rid of sine? It's called inverse sine. It's sine to the -1 power. On a calculator, it's usually right above the sine key, so you gotta hit the second button. On phones, if you hit second, that sine key changes to sine to the -1. Okay, it is the inverse sine. So I'm going to inverse sine both sides of the equal sign. So mathematically, it would look like that if I were writing it out. Notice how I did an inverse sine to the left side of the equal sign, and I did an inverse sine to the right side of the equal sign. Why did I do that? To cancel out the sine, so all that's remaining here is A, an angle A.
A equals
41.8,
Yeah.
if I go to the nearest 10, 41.8. Anybody else try it on theirs? Anybody else try to do the inverse sine of 12 over 18 and see if you can get 41.8?
That's where
You got that, Sam? Okay, 41.8. Make sure you can do that on your calculator. Inverse sine of 12 over 18, and hopefully we get 41.8 degrees. If you need help with your calculators, let me know.
And not do the second.
You'll have to do 12 divided by 18. Enter. And then to inverse sine that, you're going to go second. And then there's that inverse sine. There you go. So kind of, again, kind of a weird order there. How about you
I
guys?
didn't accidentally enter.
12 divided by 18 first. Then inverse sine, so second. There you go, 41.8. Okay. Alright, so angle A is 41.8. Now that I know this angle, can I figure out angle B pretty easy?
Yeah.
So they all got to add up to 180, so that'd be 48.2. I guess those are rounded, so 48.2 degrees. Alright. And then let's find our missing side using Pythagorean's theorem, and I'm going to refresh you on how to simplify radicals. My setup would be 12 squared plus b squared equals 18 squared. Because 18 is my hypotenuse, so it always belongs by itself. 12 squared is 144. 18 squared is 324. Subtract 144 from both sides. B squared equals 180. To get b by itself, you need to square root both sides to get rid of the squared. So b equals the square root of 180. A lot of you would type that into your calculator. It will give you a decimal answer. Some of you have wonderful calculators that will give you the simplest radical form. Lucky you. Okay? Some of you do not have calculators that do that. You're going to have to figure out the simplest radical form the best you can. Now, there's two ways to get simplest radical form. You can come up with the largest perfect square that goes into, or not necessarily, you don't have to do largest, but come up with perfect squares that go into 180. Or you can just make your factor tree, okay, which I'm guessing most of them did, okay. I'm going to do a quick factor tree here, and you'll see how I do it, okay. I know 180 is 10 times 18, and now I think I can make my factor tree mentally from there. 10 is 2 times 5, 18 is 2 times 3 times 3. Okay, so those are my factors, my prime factors that would multiply to 180. Remember to simplify radicals. If you have 2 of something on the inside, you can bring that number out to the front of the radical. So I got 2 3s, I got 2 2s, the 5 he stays by himself inside the radical. So my final answer would be 6 root 5 for the length of side B. So you found your 2 missing angles, and you got your last missing side. You left it in simplest radical form, which I'll ask you to do quite often. Any questions on simplest radical form?